Factors of a given number are numbers that have a product equal to that given number. So think of the number 8. Factors of 8 would be 4 and 2, because 4 times 2, the product of 4 and 2, is 8. Likewise, factors of a given expression are expressions that have a product equal to that given expression. You can factor many quadratic trinomials in the form of ax squared plus bx plus c into the product of two binomials. You use the FOIL method to multiply binomials, and you can use the FOIL method in reverse to factor quadratic trinomials. So the word quadratic means the highest exponent is 2, and the word trinomial means there are 3 terms involved. A little review of the FOIL method. If you're multiplying these two binomials, x plus 3 times x plus 2, with the FOIL method, remember the word FOIL tells you what to multiply. The F stands for first. That means you multiply the first terms together, x by x. The O stands for outer. That means you multiply the outside terms together, x times 2. The I stands for inner. You multiply the inner terms together, 3 and x. And the L stands for last. That means you multiply the last terms together, 3 times 2. And just multiply through that, it's going to be x squared plus 2x plus 3x and plus 6. Then go back and combine the like terms in the middle, 2x and 3x, that makes 5x. So these two binomials multiply to make this quadratic trinomial, x squared plus 5x plus 6. One thing to keep in mind, the FOIL method and the distributive property are the same things when you're multiplying two binomials. So the distributive property, if you take x times each one of these in the second set of parentheses, those would be the first and the outer terms, x times x and x times 2. And then when you distribute the 3 to the second set of parentheses, 3 times x and 3 times 2, those are the inner and the last terms. So FOIL method and distributive property are the same thing when you're multiplying two binomials. To factor x squared plus 6x plus 8 into two binomials, think of the FOIL method in reverse. So just like we used the FOIL method here and got x squared plus 5x plus 6, we're going to factor this x squared plus 6x plus 8. So it's somewhat going the opposite direction of the FOIL method. So x squared plus 6x plus 8, to factor that into two binomials. Remember, these first terms out here, x and x, made this first term x squared. So the first terms of the two binomials would be factors of this first term, x squared. They'd be x and x. Then the second terms of these two binomials will multiply to make 8, multiply to make the last term, and add to make 6. Add to make the coefficient of the x. Because back here, these second terms, 3 and 2, they multiply together to make the last term 6, and they added together. If you take the outer and inner terms, they added together to make a 5. It's the coefficient of the x. So you're looking for two numbers that multiply to make 8 and add to make 6. Two numbers that multiply to make 8 and add to make 6 would be 4 and 2. Now, it doesn't matter what order you put those down in, because you still have an x in the front of each set of parentheses. So it could be x plus 2 times x plus 4. Multiplication is commutative. You can move it around, doesn't change the outcome. So x squared plus 6x plus 8, that factors into x plus 4 times x plus 2, or you could write that as x plus 2 times x plus 4. What is the expression in factored form? X squared plus 9x plus 20. So we're going to factor that x squared plus 9x plus 20 into two binomials. Again, think about the FOIL method in reverse. With the FOIL method, the first terms of the FOIL method multiply to make this first term x squared. So there's really no choice there. That's just going to be x and x. The second terms of these two binomials will multiply to make 20, because the last terms of the FOIL method multiply to make this last term 20. And then they're going to add to make 9. So these second terms are going to add to make 9, because the outer and inner terms of the FOIL method will add together to make 9x. So think about the coefficients of those outer and inner terms. Those outer and inner terms, if they add together to make 9x, the coefficients, the number in front of the x, will add to make 9. So we're looking for two numbers that multiply to make 20 and add to make 9. So think of all the factors of 20. And everything's positive here, so all of our terms would be positive. But factors of 20 would be 1 and 20, 2 and 10, 4 and 5. You're looking for a pair that add together to make 9. So a pair that multiplies to make 20 and adds to make 9 would be this 4 and 5. Those two numbers multiply to make 20, add to make 9. Those would be the second terms of the two binomials. Now again, it doesn't matter what order you put those down in. It could be x plus 4 times x plus 5, or it could be x plus 5 times x plus 4. Multiplication, you can move it around. It doesn't change the outcome. So that x squared plus 9x plus 20, that factors in x plus 5 times x plus 4. You could multiply those back together with the FOIL method or distributive property, and you would get what you started with. That would be one way to check it. Going to factor this x squared plus 14x minus 72. Now we do have a negative here, so this is going to be a little bit more difficult. Again, the FOIL method, the first terms of the two binomials will multiply to make this first term x squared. So again, really no choice there, it's just x and x. But the second terms of these two binomials will multiply to make negative 72 and add to make 14. Because the last terms multiply to make negative 72, then the outer and the inner terms will add together to make 14x. So think about the coefficients of those outer and inner terms of the FOIL method. The outer and inner terms, the coefficients will add to make 14. So you're looking for two numbers that multiply to make negative 72 and add to make 14. If you aren't sure, list factors of 72 or negative 72. And again, since C, that last term, is less than 0, or in other words, it's negative, one factor will be positive and one will be negative. Since this middle coefficient, this 14, is positive, the factor with the greater absolute value is positive. That's a little bit confusing. We'll try to make it a little bit more simple. So we're looking for two numbers that multiply to make negative 72 and add to make 14. Think of all the factors of negative 72, and you're looking for a pair that will add to make 14. So these are the factors of negative 72. You have negative 172, negative 236, negative 324, negative 418, negative 612, and negative 89. You're looking for the pair that adds together to make this 14, and that would be this negative 4 and 18. So if you aren't sure, you want to list the factors of that negative 72 and think about which pair can you put together so that when you add them, you get this 14. And that pair we just said was negative 4 and 18. So those second terms are negative 4 and 18. Again, doesn't matter what order you put these in. This could be x plus 18 times x minus 4. Either way, x squared plus 14x minus 72, that factors into these two binomials. What is the expression in factored form? Negative x squared plus 13x minus 12. Now, before you do anything, notice the x squared is negative. If you're going to factor this, you want your x squared to be positive. So the first step here is to factor a negative 1 out of this entire expression. So you're going to divide each term by negative 1, and that's what's going to go in the parentheses. So if you divide each term by negative 1, negative x squared divided by negative 1 is x squared. 13x divided by negative 1 is negative 13x. And negative 12 divided by negative 1 is 12. Really, you're just changing all the signs. So if you factor negative 1 out, you have x squared minus 13x plus 12 in the parentheses. Now that still may factor, so we'll try to factor that. The first terms of the two binomials multiply to make this first term x squared. Really no choice there, it's just going to be x and x. The second terms of the two binomials multiply to make 12 and add to make negative 13. Now think about that. You're looking for two numbers that multiply to make a positive and add to make a negative. That means they'll both be negative. So you're looking for two numbers that multiply to make 12, add to make negative 13. Both are going to be negative. So factors of 12 would be 12 and 1, 6 and 2, and 4 and 3. The only two you can put together to make a 13 in any way would be the 12 and 1. And since they both have to be negative, those second terms are going to be negative 12 and negative 1. Again, it doesn't matter what order you write those in. Those could be switched around. Multiplication is commutative. You can move it around. Doesn't change the outcome. So completely factored, that is negative 1 times x minus 12 times x minus 1. Also, you really don't need to write the 1 there. Just the negative sign will do. We're going to factor each one of these, a, b, and c, starting with this letter a, x squared plus 14x plus 40. So to factor that into two binomials, the first terms are x. The second terms multiply to make 40 and add to make 14. Those second terms would be 4 and 10. Again, think of factors of 40. All the factors of 40, think about the pair that you can put together to make a 14. That's the 4 and a 10. So x plus 10 times x plus 4 is what that factors into. You could check that with the FOIL method, multiply those back together, you will get what you started with. Next, x squared minus 11x plus 30, going to factor that into two binomials. You know, since it's an x squared out front, your first terms are going to be x. One thing to keep in mind, when you have a number in front of the x squared, this whole picture is going to change. It's going to be a whole different method that we're doing. So x squared minus 11x plus 30, we just have x squared out front. We're going to factor that into two binomials. The first terms are x. The second terms multiply to make 30 and add to make negative 11. It'd be negative 6 and negative 5. So think of factors of 30. You have 30 and 1, 15 and 2, 6 and 5, 10 and 3. The only pair that you could put together to make an 11 would be a 6 and a 5. And since you're multiplying to make a positive and adding to make a negative, they're both going to be negative. So it'd be x minus 6 times x minus 5. Finally, down here on the end, negative x squared plus 14x plus 32. Notice that x squared is negative. So you need to factor a negative 1 out of this entire expression. Divide each term by negative 1. That just changes all the signs. It'd be negative 1 times x squared minus 14x minus 32. Now that factors into two binomials. The first terms of the two binomials make x squared. So the first terms of the two binomials would be x and x. The second terms of the two binomials multiply to make negative 32 and add to make negative 14. Now think of all the factors of 32. You have 16 and 2, 32 and 1, 8 and 4. The only possible pair that you can put together to make a 14 would be that 16 and 2. One of them will be positive and one will be negative because you're multiplying to make a negative 32 and you're adding to make a negative 14. So then you have to decide which one is negative so that when you add them together, is the 16 negative or is the 2 negative, so that when you add them together, you get a negative 14. So is it negative 16 and 2 or is it positive 16 and negative 2? You're looking for the pair that adds together to make a negative 14, and that would be negative 16 and positive 2. So negative 1 times x minus 16 times x plus 2 is what that factors into. You really don't need the 1 there, just the negative sign will do. Also keep in mind you can check your answer. You could distribute that negative sign through that first set of parentheses. It'd be negative x plus 16, and then use the FOIL method with what's left there, and you will get what you started with. So for all of these, you can check your answer by going in reverse. Use the FOIL method, distributive property, whatever is needed, and you will get what you started with. The greatest common factor of an expression is a common factor of all the terms in the expression. It is the common factor with the greatest coefficient and the smallest exponent. So when you're looking for the greatest common factor of an expression, you're looking for the common factor with the greatest coefficient of the terms and the smallest exponent. Especially when you're dealing with variables there, you're looking for the smallest exponent when you're looking at the greatest common factor. So for example, 6x squared plus 9x, what is this expression in factor form? Well, we're going to factor out the greatest common factor. So to do that, it's really not hard. Look at the 6 and the 9. What's the greatest common factor? What's the largest number that goes into both 6 and 9? 3. So 3 is the greatest common factor of 6 and 9, but that is not the greatest common factor of the expression. That's just the greatest common factor of 6 and 9. You still have this x squared and x. And up here it says you're looking for the one with the smallest exponent. So the greatest common factor of x squared and x is x. So put those together. The greatest common factor of 6 and 9 is 3, and the greatest common factor of x squared and x is x. So the greatest common factor of those two terms would be 3x. So what we're going to do is factor that out. When you factor that out, you're dividing each of these terms by that 3x. So if you divide 6x squared by 3x, that is 2x. And if you divide 9x by 3x, that is 3. So it's somewhat going the opposite of the distributive property. We're factoring a 3x out. We're dividing each of those terms by 3x, and that's what goes in the parentheses. 3x times 2x plus 3. You want to check that? Just use the distributive property. You'll have what you started with. 4x squared plus 20x minus 56. Whenever you are factoring anything, you always want to look for a greatest common factor that you can factor out. So if you look at these terms, 4x squared, 20x, and negative 56, think of the 4, the 20, and the 56. Is there a common factor of those three numbers? There is, and it is 4. So we're going to factor a 4 out. We're going to divide each of these three terms by 4. So if you divide 4x squared by 4, that's x squared. If you divide 20x by 4, it's 5x. And if you divide negative 56 by 4, that would be negative 14. So we factored a 4 out. That was the greatest common factor of those three terms. There was no x attached to it because there is no x attached to this negative 56. So x is not part of the greatest common factor. It's simply 4. But we still may be able to factor this x squared plus 5x minus 14. So you don't just want to stop there and call it good. Try to factor that into two binomials. So the first terms of those two binomials would be x. The second terms multiply to make negative 14 and add to make 5. So you're thinking of factors of 14. You have 14 and 1, 7 and 2. One of them will be positive and one will be negative because you're multiplying to make a negative 14 and adding to make a 5. And thinking about which one is positive, which one is negative, is it the 7 or the 2? Well, they have to add to make a 5. So the 7 is going to be positive and the 2 will be negative. Because when you add those, that is a positive 5. If you had the sign switch where you had negative 7 and 2, those add to make a negative 5. You want to add to make a positive 5. So completely factored. We factor out the greatest common factor of 4, and then we factored that quadratic trinomial into these two binomials. So completely factored, that is 4 times x plus 7 times x minus 2. Which of the following is equivalent to the expression 3a squared minus 2b squared plus b? There is no greatest common factor here. There is nothing that goes into all three of these evenly. These last two have a b attached to it, but the front one has an a attached to it. So there really is no greatest common factor of all three terms. But if you look at the last two terms, the negative 2b squared and the b, there is a common factor there that you could factor out. And keep in mind, you have to match one of these answer choices. So looking at those last two terms, you could factor a negative b out. So if you factor a negative b out of those last two terms, divide negative 2b squared by negative b almost. Divide negative 2b squared by negative b, that would be 2b. And divide b by negative b, that would be negative 1. So taking those last two terms, factor a negative b out, and you'll have this negative b times 2b minus 1. So the answer that matches up with is this letter D. So it might throw you off a little bit. You might be looking for a common factor when really there is no common factor of all three terms, but there is a common factor of the last two terms. And normally we call it the greatest common factor. I wouldn't say that's the greatest common factor because really a greatest common factor there would be b. So we're really just factoring out a common factor that's going to work here, that's going to get us the right answer. So negative b is not necessarily the greatest common factor, but it is a common factor that worked for this. Letter D is the correct answer. Which of the following is a factor of x squared minus x minus 12? So we're going to factor this into two binomials and then see if we get one of these factors. So to factor this into two binomials, the first terms of the two binomials, since we have an x squared out front, the first terms would be x. The second terms of the two binomials will multiply to make negative 12 and add to make this middle coefficient negative 1. So you're looking for two numbers that multiply to make negative 12 and add to make negative 1. So think of the factors of 12. You have 12 and 1, 6 and 2, 4 and 3. Which of those can you possibly put together to make a negative 1? 12 and 1 wouldn't work, 6 and 2 wouldn't work, but the 4 and 3 would work. Now, they're multiplying to make a negative 12 and they're adding to make a negative 1. So those second terms would be negative 4 and positive 3. If you went positive 4 and negative 3, those add to make a positive 1. We want to add them to make a negative 1. So second terms are negative 4 and 3. These two binomials are x minus 4 times x plus 3. And the correct answer here, the one with the correct factor, is letter D, x minus 4. If R and S are constants, and x squared plus rx plus 12 is equivalent to x plus 3 times x plus s, what is the value of r? So this x squared plus rx plus 12 is equal to, or factors into, x plus 3 times x plus s. You need to find the value of r. Seems confusing, but you've done it before. X squared plus rx plus 12, that factors into x plus 3 times x plus s. Now think about the FOIL method. When you multiply these last terms together, 3 times s, that is 12. If you get the value of s, that's going to help you. Because if you get the value of s, then you can figure out what r is. So to get the value of s, again, these last terms, 3 times s, that is equal to 12. Those are the last terms of the FOIL method. So if 3s equals 12, that means the value of s is 4. Now, if we know the value of s is 4, we can put that in and take x plus 3 times x plus 4, and then we'll be able to find out what this middle coefficient is, what that r is. So take and substitute 4 in for s. We have x plus 3 times x plus 4. It's just FOIL method or distributive property from there. So multiply x plus 3 by x plus 4 with the FOIL method distributive property. The first terms are distributing the x to the x, it's x squared. The outer terms, or distributing the x to the 4, it's 4x. The inner terms, or distributing the 3 to the x, is 3x. And the last terms, distributing the 3 to the 4, that is 12. Combine the like terms in the middle. 4x and 3x is 7x. So the question was, what is the number in front of the x there? What is r? Well, you can see it right now. It's 7. So r is 7, and the correct answer is C.